Hello guys. So today we'll be discussing about something called IHD, that is Index of Hydrogen Deficiency. Now, what it is required for and why are we studying this? First of all, we are studying this because in IHD many a times it has been asked, and in NEET also it has been asked many a times how to calculate the number of constitutional isomers of a molecular formula that is given to you. Now, suppose I have given you a compound named C2H4 and asked you that how many double bonds are there. By just looking at it, you know that it is a alkene, and you have said me, sir, 2 double bonds are there. I give you something like C2H2 and I ask you how many pi bonds are there. You know about this compound and you let me know, sir, there are 2 pi bonds and a triple bond in this compound. So pretty easy when we are talking about simple compounds. But if I ask you how many double bonds are there in C17H36, then it becomes difficult for you to find out this kind of problems. There may be 2 double bonds, there may be 1 double bond, there may be triple bonds. Yes, you will use that formula CnH2n, CnH2n plus 2 to get the idea whether it's a alkane or alkyne. But what about cycloalkanes? What about bicyclo compounds? There can be so many numbers of permutations and combinations that will devolve in your mind and you will get confused. So, how to find out the isomers? First of all, let us just get the feel of what is hydrogen deficiency. Let us take the simple compound C2H6. Okay, C2H6. This is ethane and we all know it. Now, does it have any double bond? No. Ethene, does it have a double bond? Yes, it does. Ethine, does it have a double bond? No, it has a triple bond, but okay, double bond, 2 double bonds make a triple bond, you can say that, right? So, this is C2H2. Now if I ask you which compound among these 3 is most unsaturated, you will directly come up with the answer, sir, C2H2, it is having triple bond. You are correct, but suppose I do not want to get a qualitative answer and I want to get a quantitative answer from you. That means you will give me a number or figure by which I can understand that the unsaturation degree of this compound is how much more than this one. Can there be a number possible? Can we quantify these things? That is where the need of index coming up, and we have to calculate the index of hydrogen deficiency, because see, this is hydrogen deficient, much more hydrogen deficient than this one, and this one is hydrogen deficient than this one. So what is the index? What is the number by which you can signify the hydrogen deficiency of a compound? That's what we have to calculate. Not only this is called IHD, this is also called double bond equivalence. Must have seen in many of the books, double bond equivalence. DBE. You can also name it as a measure of degree of unsaturation, right? You can do it. So first of all, we have to assign some numbers to it. If we can assign some numbers to it, then we can develop some scientific methods of finding out how many numbers of isomers is possible. So first of all, we'll have to assign some numbers to it. So let us see. So see, if we have to calculate the IHD, we must be having some formula. The formula of IHD is this. Summation n, which is the number of a particular atom, V, valency of that atom, minus 2 plus 2 divided by 2. Let us calculate for ethane. Ethane, first of all we will take, because here there is a summation, first of all we will take the carbon atom. there are 2 carbon atoms, so 2 number of carbon atoms. Valency of carbon is 4 minus 2 plus 2. So how much is it? This is only carbon that I have taken. What about hydrogen? There is a summation sign, right? So you have to take hydrogen also. Plus, how many hydrogens are there? 6. Hydrogen valency is 1 minus 2. Now this completes the total summation. You have to take each and every element of the compound. If there is oxygen, you have to take that. If there is a chlorine, you have to take also that. So this is the universal formula. And at the end of the day, this plus 2 is coming out. So if you calculate this one, 2 into 2, 4 minus 6 plus 2 whole divided by 2, this will be 0. This will be 0. Okay? IHD of ethane is 0. That means the hydrogen deficiency of ethane is 0. And that is correct. Ethane is not hydrogen deficient, right? Ethane has plenty of hydrogen filled up in its all the 4 arms, right? They have a lot of hydrogens. Now let us check what happens with ethene. How many carbons are there? 2 carbons, so nothing changes over here. 4 minus 2. 4 hydrogens are there. So here there will be a change. Okay. A second. Okay. So here if we see 2 to the 4 again, minus 4 over here plus 2 by 2. So this will come out to be 1. So in ethene there is some index of hydrogen deficiency. That means there is some degree of unsaturation. Okay, there is some degree of unsaturation in ethene, which we can denote by IHD value of 1. So if there is a IHD value of 1, the bond is there must be a double bond. Okay, if there is a IHD value of 1, there must be a double bond. Okay. Now we'll come to ethyne and let's check for ethyne. So see, in ethyne also the first part will not change. There is 2 carbon atoms. Only the second one will change. This will be 2. So this will be, so 4 plus 2, 6 minus 2, that is 4 by 2. So IHD of ethyne will be 2. So obviously if you see the IHD of ethene was 1, there was a double bond. IHD of ethyne is 2, that is there is a triple bond. So if the IHD is 2, not only there can be a triple bond, there can also be 2 double bonds. Basically 2 means 2 pi bonds and 1 means 1 pi bond. Now let us do one example. Which will make it clarified much more, and with some other complications will also come up. C3H6. You know this is propene, right? You know this, but still let us try this one. What is the IHD over here? 3 into 4 minus 2 plus there is 6 hydrogen atoms, 1 minus 2 plus 2 all divided by 2. So 3 into 2, that is 6 minus 6 plus 2 all divided by 2. 6 will cancel out, 2 by 2 will be 1. So obviously it's having a double bond and there is a hydrogen deficiency of 1. So what can be the possible structure? One is this one. You can fill up the hydrogens easily. There is no other structure. But remember, in case of a double bond, you can also replace the double bond with a cycloalkane. Don't forget this. You remember what is the formula of cycloalkanes? It basically matches with the formulas of the alkenes. 2 hydrogens, 2 hydrogens, 2 hydrogens. C3H6. So it matches. So basically, if IHD is 1, if IHD value is 1, there can be possibilities of alkene, there can be possibilities of cycloalkanes. That means there can be a ring. If IHD value is 2, there can be triple bond, there can be 2 double bonds, there can be 1 cyclic ring and a double bond plus a double bond. There can be 2 cyclic rings, which means bicyclo compound. 4 possibilities are there if you go for IHD value of 2. Okay, there are 4 possibilities. So this is how I get an idea that what kind of IHD value is there, and by that I get the basic idea that how many number of isomers will be there. What are the possible isomers or possible kind of bond arrangement that is possible in this molecular formula, whatever is given to you. So now what we will do is we will try to find out a very simple compound, that is C3H7Cl. So you will find out the IHD value of this and try to find out all the constitutional isomers of this one. Remember, if IHD value is 0, then it is a simple alkane, no cycloalkanes. Okay, it's a simple alkane, no cycloalkanes. If IHD value is 2, it may be alkene or cycloalkane. If IHD value is 1, it can be alkene or cycloalkane. If IHD value is 2, it is a triple bond, or 2 double bonds, or a cycle and a double bond, or 2 cycles. Okay, so first you practice this one, and then one by one we will also discuss all those things also, which is having a little bit more complication and nothing else. Remember, this has been asked many times in our JEE and NEET examinations, and these are very easy things. Once you practice with different type of examples, things become very easy for you. So I would request you, not only you go through this video, but also practice. Okay, you take your pen and paper and practice all the time, so that you get the confidence of doing this kind of problems while given in the examination. Okay, so you practice this one first, give me the answer, and after that we'll continue. Okay guys, so have you solved this one? So what will be the IHD value of this? You must have solved this one. Let us do it again. 3 carbon atoms, 4 minus 2, 7 hydrogen atoms, 1 minus 2, 1 chlorine atom, 1 minus 2 plus 2 whole divided by 2. So 3 into 2, 6 minus 7 minus 1 plus 2 whole divided by 2. So it will be 6 minus 8, that is minus 2 plus 2, 0. So IHD value will be 0 in case of C3H7Cl. What does this signify? If IHD is 0, there is no double bond, no ring. If IHD is 1, there is double bond or ring. Okay. So there is no double bond, no ring. So it will be a simple long chain compound like this. So first you have to draw the skeleton like this, and then chlorine can be here also, or chlorine will be in the middle carbon. You can fill up the hydrogen by your wish, because you will just put up 4 arms of each carbon and put up the hydrogens there and there. Okay, that's it. Next. Let us take a complicated compound C3H7Cl N2O, and let us just take the IHD, nothing else. So let us calculate the IHD. 3 carbon atoms, 4 minus 2, practice karo yaar, plus 7, 1 minus 2 plus 1 chlorine atom, 1 minus 2 plus 2 nitrogen atoms. Nitrogen has valency of 3 minus 2 plus oxygen 1 atom, 2 valency minus 2 plus last में 2 divided by 2. ये 0 हो गया आपका. This will be 6 minus 7 minus 1 plus 2 plus 2. So whole divided by 2. कितना आता है? 6 plus 4 will be 10, minus 8 will be 2, 2 by 2 will be 1. So see, for any kind of compound you can easily calculate the IHD. So ये वाला जो bond होगा, whatever this compound is, this will have a double bond, this will have or may have another isomer, may have the ring structure. Okay, so this is the way you have to calculate IHD very fast. This is the one formula that you need to remember. Then the things will be pretty easy for you. Now let us go for a little bit complicated structure, C3H6O. Okay, simpler than the other one we did. So let us first calculate the IHD value of this one. धीरे धीरे करो. There is no hurry. So let us go very slow. IHD 3 carbon atoms. 4 minus 2 plus 6 hydrogen atom. 6 1 minus 2 plus 1 oxygen atoms. 2 minus 2 plus 2. So 3 into 2 6 minus 6. ये तो 0 हो गया plus 2 divided by 2. IHD value is 1. So what does this mean? IHD value is 1 means either there is a double bond or there can also be a ring. So one by one we will be doing. First of all we will be drawing the straight chain ones and then we will be doing the ring. It is pretty clear. Either you will get a double bond or a ring. So let us first have straight chain ones. ठीक है? So this can be a possibility. Okay, this is a possibility for a straight chain one. Or what can be the other possibility? It can be this also. Okay, another one. Okay, so these are the 3 chain possibilities that I can see. Now where can the double bond stay? The double bond can stay over here. Okay. Okay. Now the double bond can stay over here. Double bond can stay over here also. Okay. Now anything else? Can I get anything else? Now from here I can get another structure. I think 3 3 C. में double bond लाना पड़ेगा. I can go for this as single bond and I can make this double bond also. So there is another possible structure isomer that is there. Okay. Anything else? Okay, I can go for this one also. C O. So this is double bond. C. This is also possible. So there are 5 structure isomers I can see at this moment. Anyone else? Anything else? Is there anything else? Let us find out if there is anything else that we can do with this one. So this is one of the structure which is duplicated at this one. This is also duplicated like this. Just the double bond has shifted from this to this. Nothing else. Anything else is there that we have to find out. Okay. देखो. From here I can do another one. ठीक है? This is also possible. I think so. Here for this one I am getting 3, and this one you cannot change. This is only one isomer possible. So 3, 2, 5, and 6 isomers. 6 straight chain isomers. ठीक है? 6 straight chain isomers that we are getting over here. So how did we proceed? We remembered only one thing, that is there will be one double bond. So I first created the chain. There can be this kind of chain, there can be this kind of chain, and there can be this kind of chain. Now for this kind of chain, I have tried to find out what are the other positions of the double bond. So here it can be and here it can be. There are 2 positions of double bond possible. And for this kind of chain, if you see, there is no other option that I have got, because I cannot put a double bond over here because this oxygen is also bonded to another carbon. So this is only having one isomer. Another one was this kind of chain. For this kind I had an option, so I did another. So there are 6 straight chain isomers over here. Now let us see if there is IHD of 1 and obviously it is having one double bond, that means it can also have a ring structure. ठीक है? So here से आपका 6 निकल गया. You please fill up all the hydrogens in this structure and write down. Now we will go for the ring structure. Now what kind of ring structure that is possible over here? Let us see. One is three carbon atoms, oxygen. This is possible. Another is oxygen atom. ओके, ऑक्सीजन का 2 हो गया तो इसमें एक कार्बन रहेगा, ठीक है। ऑक्सीजन यू कैनॉट पुट अनदर कार्बन बिकॉज़ ऑक्सीजन का 2 ब्रांच खुल गया है। नेक्स्ट, एनीथिंग एल्स? यू हैव पुट ऑक्सीजन एटम, सो 3 का हो सकता है। अच्छा, देयर आर 4 एटम्स, राइट? इफ यू सी, ऑक्सीजन कैन आल्सो बी अ पार्ट ऑफ द रिंग. This is also possible. So we can get another 3 isomers which is having ring structures. Okay, so 6 isomer plus 3 isomer will be having 9 isomers. Okay, so see, it is much more scientific right now. As you know, the IHD value is 1. That is why you can understand there can be one straight chain one. So in case of straight chain or the open chain ones, you will have one double bond. That is for sure. And another option is ring chains or cyclic ones. So both the things we have covered over here. You can put the hydrogens wherever required. Now let us take the homework compound. C4H6, right? That was the homework compound. Many of you have given answers as 5 and some of I think you have given 6 also. So let us calculate IHD again. What is the IHD value coming? 4 into 4 atoms of carbon into what is the valency? 4 minus 2 plus 6 atoms of hydrogen. 1 minus 2 plus 2 divided by 2. So 4 2s will be 8 minus 6 plus 2. Okay. So 8 plus 2, 10 minus 6, that is 4 by 2. IHD value is 2. Okay. Now it is not 1, it is 2. IHD value is 2 over here. There will be a triple bond. Okay. 2 pi bonds. Remember, if IHD value is 2, there will be 2 pi bonds. Or there may be something with the rings. Okay, we'll check. We'll check. What are the possibilities first of all? One is 2 double bonds, right? 2 double bonds also mean 2 pi bonds. 1 triple bond. We also know a single double bond or a double bond, one double bond is equivalent to a cyclic structure. So cyclic will have one double bond plus one double bond is also possible. Anything else? Okay. I can also write cyclic, that is one double bond plus cyclic, 2 double bonds. So there can be an option of 2 cycles in one compound. Remember, bicyclo compounds. We have already studied bicyclo compounds. That is also possible over here as per our assumptions. So we will have to check what are the possibilities. First of all, for open chain ones, we have to first check this two. C4H6. Skeleton structure. 2 double bonds. It can be here, it can be here, or it can be here and here, right? Okay, हो गया आपका 1, 2. Next, ये वाला हो गया. There is no other options. If you see, there is no other options. Next is 1 triple bond. Here it is possible, or in the middle. Okay. If you put it here or here, it doesn't change. So number 3, number 4, ट्रिपल बॉन्ड के लिए भी आपका 2 कंपाउंड हुआ, डबल बॉन्ड के लिए भी 2 कंपाउंड हो गया. Now ring structure, cyclic plus double bond. Let us see how it is possible. Cyclic structure is there. डबल बॉन्ड कहां बैठा होगा भाई? बाहर का तो कोई कार्बन है नहीं, सब हाइड्रोजन है. हाइड्रोजन will not form double bond, so you have to put it over here. There is one possibility. Now let us form a cycle with 3 carbons. This is also possible. So here you can go for this one, or this one also possible. ठीक है? Okay, this is also possible. डबल बॉन्ड के साथ वाला कार्बन के साथ ये वाला कार्बन लगा दिया, तो हाउ मेनी स्ट्रक्चर्स आर गेटिंग पॉसिबल ओवर हियर? 1 2 3 4. Okay, so 4 structures are possible in case of cyclic plus double bonds. If you put it here also, then this structure and if you put like this C double bond C, okay, so here instead of this, if you put it here, then you are basically copying this structure, so there is no difference, so this will not be there, only 4 structures, so 4 5 6 7 8. और ये cyclic plus cyclic भूले तो नहीं? Okay, let us go for this one also. So this will be C, 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 C. And this one. 2 cycles is equivalent to 2 double bonds. So you can fill up the hydrogens easily. So see, there are 9 structures of this compound. So now you have the idea of how to use the IHD to find out the number of constitutional isomers of a hydrocarbon. If you have any problems regarding this lesson, let me know. We'll clarify. Okay? Thank you.